Hello everyone and welcome to this tutorial. Till now we have completed all the data pre-processing steps. First we have imported the libraries and dataset, then we have done data exploration, then we have dealt with the missing values and categorical data. After that we have plotted count plot, correlation matrix and heat map, and then we have defined x and y, that is matrix of features and our target variable. And after doing that we have splitted the dataset into train and test set, and at the end we have applied feature scaling. So these are the all data pre-processing steps. So from this tutorial we will start the model building process. Let us begin. For this specific project we will apply two different classification machine learning model. First one is the logistic regression and second one is the random forest regression. And after analyzing which model is performing better, we will finalize this model. So let us start with the logistic regression. Create a subsection. Logistic regression. And as we have discussed earlier, we can always refer the official documentation for the sklearn. So open new tab. Go to sklearn documentation. Go to API. Here we have to search for linear models. Scroll down. All these are in an alphabetical order. Linear models. Now go to logistic regression. So this is the class that we have to import, logistic regression, and we have to import this class from sklearn.linearModel, and here you can get all the details about the logistic regression. These are the parameters, but as of now we will use logistic regression with the all default parameters. Now go to Google Colab notebook. First import the logistic regression class from sklearn.linearModel and then import logistic regression and execute. Now go to again official documentation. Scroll down. We have to look for the examples. So this is the example. You can see here. First we have to create an instance of this class. And after that we have to train the model by using .fit method. Go to Colab notebook. We will call our model as classifier underscore LR, that is logistic regression. Specify random state is equal to 0 and execute. So here we have successfully created an instance of this class, logistic regression, and we have specified random state is equal to 0. Due to random state, your and my output will be same, nothing else. Now add some cells. Now we have to train our model. To train our model, use this instance, classifier underscore LR dot fit method, and in parentheses we have to specify the training data, x train and then y train. That's it. Execute. So here we have successfully trained the logistic regression, and these are the details. You can see these are the default parameters. Now we have to make the predictions. Define a variable ypred is equal to classifier underscore LR, this is our classifier, dot use predict method, and in parentheses specify the test data, that is x test, and execute. So here we have successfully created a variable with the all predicted values, and to do that we used this method .predict method. Now we have to analyze the performance of our logistic regression model. To analyze the performance of logistic regression model, we have to import various classes. Let us refer official documentation. Now scroll down, go to matrix, this one, and here we have to import few classes. First one is the accuracy score. After that, F1 score, then precision, we will use precision score, then recall score, and we have to import one more class, this one, confusion matrix. So we have to import confusion matrix, accuracy score, F1 score, precision score, and recall score. And this was the logistic regression. So let us understand. So we use confusion matrix to check the number of correct predictions and number of not correct predictions. So you may be familiar about this one, confusion matrix. Let us move forward. Then accuracy score. It will calculate the accuracy for our model. The next one, F1 score. This will compute F1 score, this class, and it is also known as balanced F1 score or F measure. And F1 score can be interpreted as weighted average of precision and recall. And you can see here F1 score reaches its best value at 1 and worst value, that is worst score, at 0. And this is the formula to calculate the F1 score. 2 into precision into recall, and this is all divided by precision plus recall. So this is the F1 score. 0 is worst and 1 is beta. Let us move forward. Then we have to calculate precision score, and this is the formula to calculate the precision, TP divided by TP plus FP. TP is number of true positives and FP is number of false positives. And here also same, best value is 1 and worst value is 0. So let us move forward. Recall score. This is the formula to calculate the recall score, TP divided by TP plus Fn. TP stands for true positive and Fn is the number of false negatives. And here also same, best value is 1 and worst value is 0. So these are the parameters that we have to import. So with all these parameters, we will analyze the performance of our logistic regression model. Now go to Colab notebook. First we have to import all these classes from sklearn dot matrix import. First we will import accuracy score, then confusion matrix. Let us see what we have to import. Confusion matrix, accuracy score, F1 score and precision score. F1 score, then precision score, this one, and after that recall score. And execute. Add few cells. Now define a variable ACC. This is for accuracy score, and use this class accuracy score. And here we have to specify two parameters for the accuracy score, y true and y pred. So y true means y test, comma y pred. Then again define one more variable f1. Use the class f1 score. We have to specify same parameters, y test and y pred. Then define precision, PREC, precision score, specify same parameters, and at the end define REC, that is for recall score, and same parameters. Now I will define a data frame. I'll just paste here this one. So here we are defining a data frame. First we are specifying logistic regression. This is the classification model that we are using. Then we are specifying all these variables that we have defined: accuracy score, F1 score, precision score, and recall score. and we are just providing their names. Now execute. Check the result. Model is logistic regression. Accuracy is 0.96, that is more than 96%. Then F1 score 0.95, precision score same 0.95, and recall score is also same. So here we can say that we are getting a nice accuracy. Now we have to plot the confusion matrix, define a variable as CM, that is for confusion matrix. Use the class confusion matrix and specify the same parameters y test and y pred. Then print the confusion matrix. Execute. So this is our confusion matrix. 65 and 45 are the correct predictions, and these 2 and 2 are the wrong predictions. Now we have to do one more important step here. Add one more section. Cross validation. Let us refer the official documentation, this one, and we have to search for model selection. This one, cross-val score. Close all the tabs. So using this class cross-val score, we can evaluate the performance of our classification model. Let us see how. First we have to import this class, and we have to import this class from sklearn.model-selection. I'll just copy this one from sklearn.model-selection, then import cross-val score. Execute. Great. Now define a variable accuracies is equal to, use this class cross-val score. In parentheses we have to specify arguments. Let us check for that. First we have to specify estimator, this one. Estimator, this is our classification model, classification underscore LR. Let us check for next parameters, X and Y. So we will specify X is equal to X train and Y is equal to Y train. So here we are evaluating the performance of our model on the basis of X train and Y train. Now we have to specify one more parameter, this one CV. Let us check CV. It determines the cross-validation splitting strategy. Possible inputs are this one. So we will specify a number. We have to specify just cross-validation fold. So I will specify 10. Let us understand what we are doing here. So this cross-validation technique will compute 10 different accuracies on the basis of X train and Y train. And every time it will take random inputs from X train and Y train. We can try for different accuracies as well. To do that we have to specify a number here, how many accuracies that we want. But as of now we are computing only 10 accuracies. Now execute, add a few cells. So here we have to compute accuracy mean and standard deviation. I will paste a code here, this one. So here we are getting accuracy mean in terms of percentage and standard deviation also in terms of percentage. Execute. Great. So accuracy is 97.81 and standard deviation is 1.98. Let us check previous accuracy. Previously we have accuracy as 96.49%. By using the cross validation, accuracy is increased. This is the average, or we can say mean accuracy, and this is the standard deviation. We can say standard deviation is a range 97.81 minus 1.98 and plus 1.98. This is the range. So let us revise what we have done till now. In previous tutorials, we have done all the data pre-processing steps. Here we are building the model, and first model is logistic regression. So first we have imported the logistic regression class. After that we have created an instance of this class, and then we have trained our model. Here we have specified X train and Y train. After that we have done the predictions and we have stored this in a variable ypred. And after that we are analyzing the model performance. And to analyze the model performance, we are using all these parameters: accuracy score, confusion matrix, F1 score, precision score, and recall score. And these are the details. And after that we have checked the confusion matrix, and at the end we have applied cross validation. That means we are computing 10 different accuracies, and after that we have taken the mean of all these 10 accuracies. So this tutorial about the logistic regression ends here. I will see you in the next one. Till then, happy learning.